Hello, this is Miss Lipsey. This is a little bit of a different recording because the recording I did for this lesson did not record at all what I was writing. So I'm going to be talking through this after it's already been finished, just so you have the lesson, you have a better understanding, okay? This lesson is covering domain. Domain is talking about all of our x values, our input values, our independent variable values. All three of those things mean the same thing. But in this context, it's all the input values because we're viewing domain like numbers on a number line. So we read numbers on a number line from left to right, where the left side is negative numbers and the right side is positive numbers, where zeros in the middle to split them in half. So if I'm looking at example number 1, I'm dealing with two endpoints, where the open circle on -4 means not equal to, and the closed circle on 2 means equal to. That means think inequality. We have inequalities, we have 4 basic symbols. We have greater than, less than, greater than or equal to, or less than or equal to. When you think open and closed, that's the equal to or the not equal to. So I shaded what's in the middle because it's a little bit harder to read from the copy to here. On the original copy this was red, but we only have black and white, so we have to work with what we got. So the shaded area is saying that we're dealing with numbers between -4 and 2, with -4 being not included and -2 being included. So that's why my answer would be that of -4 is less than x, which is less than or equal to 2. Number 2 is dealing with a different type of example where we have one endpoint and an arrow. We still identify the endpoint as open or closed in the number that it is. So it's on -1 a closed circle, which means equal to. But then we have to make note that the arrows at either end are signifying either positive infinity or negative infinity. This arrow is pointing towards a negative infinity. So when we only have one point, the variable should be written first, and then since it's pointing in the left direction, that is less than -1. Example number 1 is a close example of our number 1 at the top, which means we have two endpoints where the first one's on 1 and the second one's on 7, and we're using the numbers in between. Closed means it's going to be equal to, closed means it's going to be equal to. We will always use less than. When it's two numbers, x will always be in the middle, so we read it as 1 is less than or equal to x, which is less than or equal to 7. B is another example of example number 1 at the top, where we have two endpoints, where one of them is at -6, it is closed, so it'd be less than or equal to, and the other one being open at 0, which makes it just less than. No or equal to sign. Since it falls in the middle, x should also fall in the middle, so altogether it should be -6 is less than or equal to x, which is less than 0. If I'm looking at D, this closely resembles example number 2, where I have one endpoint. Automatically x should be written. X pointing in the right direction makes greater than or equal to, because the closed dot, -5, because the arrow is approaching a positive infinity. So my answer should be x is greater than or equal to -5. E is another example of example number 2, where I still have an endpoint and an arrow, but this endpoint is open at 3, pointing in the left direction, making this less than x. So x is less than 3 because it's pointing in the left direction. That's also pointing in the left direction. X is less than 3. Now our final example for this is, what if there are no points at all, meaning the entire line is highlighted? That means it's approaching both negative infinity and positive infinity, meaning all x values are being hit. So this is what we saw on bell work this morning. This can be written as x is equal to r. This is interval notation. This is inequality notation. Okay. This is a table where there's 4 different cases in which you can use to work. The biggest thing we need to focus on is this rectangle up here Focusing on this rectangle is the most important thing, because if you do not know anything, you should know what's in here. This table can help, but it seems to be confusing more people than it's helping, so we're not going to stress too much on it. We're going to focus on, since we read from negative to positive on a number line left to right, the inequalities are always less than when we're dealing with two endpoints. An open circle means not equal to. A closed circle means equal to. An arrow going off the grid means infinity, but infinity symbols are not allowed. I don't agree with that last statement, because we can write infinity symbols, you just have to know the correct notation. That's going to come on Wednesday and Thursday's lesson, and also when we start talking about these type of functions more in depth in Unit 4. So we have a few examples. The first one has two endpoints, where the leftmost point is at -2 and the rightmost point is at 4. We treat this just like example 1 on the first page, where the smallest one, the leftmost one, comes first. So we have -2, it's a closed dot, is less than or equal to x, which is less than or equal to 4. It's equal to because both of these have endpoints. Looking at example B, we have an endpoint and an arrow. This looks more like example number 2 on the first page. It says, what if there is not a point on one side? That means the graph does not stop, making this an arrow pointing in the left direction towards negative infinity. And that's why our first value to the left is negative infinity. The rightmost value is -1. Being a closed dot, if we only have one point, that means x automatically comes first. X in the left direction is less than or equal to -1. This is just referencing the chart above. You do not need to know that part to help you with your understanding, but some people see it through the chart a little bit easier. But most people see it this way, simple enough. Use your discernment to determine which one is the best example for you. Okay. Example C says, what if there are points at the top and at the bottom? For domain, we only care about the furthest left and the furthest right point. We're only talking about the x-axis, so which means we're only focusing on the leftmost and the rightmost. Even if you do not see a point, if it's hitting the line, it is included. So you cannot see an open dot. It is closed. If you cannot see an open dot, it is closed. So the leftmost x value being used is -4, with the rightmost x value being 5. There are two endpoints here, meaning we use it like example number 1 on the first page. -4, less than or equal to, because it's assumed closed. X, which is less than 5, because that is an open circle. Letter D is more like our very last example at the bottom of the page on page 1. What if there are only arrows on the left and the right? That means this arrow is approaching negative infinity. That's the leftmost x value. And the right arrow is approaching positive infinity. That's the rightmost x value. On the chart, it tells us the absolutes, those infinities cancel out, leaving just all real numbers completely. So that means x can be any real number on the number line. So x equals r is the appropriate thing to put. Looking at the next one, it says, what if there are no points or no arrows? We do it similar to example C at the top. This is a closed shape. The edges are the points, so which means find your rightmost edge and your leftmost edge. The leftmost edge is -3, the rightmost edge is +3. You write the domain similar to how you wrote it on example number 1 on the first page. So it'd be -3 is less than or equal to x, which is less than or equal to that of 3. Again, if you cannot see an open dot, assume it is closed. And finally, example F. It says, examine the graph at right. What if the graph is not connected? This is called a discrete graph. We referenced this last week during bell work. It just means a graph made of dots that are not connected. So we start at the very left and we make our way to the rightmost one, and where we don't repeat the numbers, and we write it in a curly brace separated by commas. So my leftmost one is -5, -4, -3, 1, 2, 4. Now you do questions 1, 3, and 4. Pause the video and unpause it whenever you get those 4 done. Well, those 3 done, excuse me. Here is the answer for example number 1. Here are the answers for examples number 3 and 4. Be sure to complete all other practice problems. Attend tutoring if you need assistance. Contact me. Let me know what you need. Rewatch the video if you need to as well. And study hard.